So we are still looking at this topic here of bundling or building more generally. And I want to walk through the remainder of the slides, this section. So if you can remember from last week, the basic idea of bundling is where on the left we have our source code, and our source code consists of lots of modules. Some of these modules will be definitely JavaScript, others might be CSS. In terms of the JavaScript, a module might contain just pure JavaScript, or it might contain other languages that can be converted into JavaScript, like TypeScript. In terms of modules that contain CSS, it may be raw CSS, or it could be something that can be converted into CSS, like Sass. Either way, we've got what's called a dependency graph on our left, which contains all of our modules and the dependency relationships between them. And what bundling involves is taking all of these modules on the left and creating what we see on the right. And what we see on the right are a smaller number of files in simple terms, but those files will contain either all or some of the JavaScript from the left. It may contain all or some of the CSS from the left. So what's happening is the modules on the left are being bundled or packaged into larger units on the right. We refer to these things here on the right as our bundles. They're also referred to as chunks. And the transformation from, or the conversion from the left to the right is, in the case of a web app anyway, is performed by a tool called Webpack. There are alternatives to Webpack, but Webpack is the dominant one. Now, as well as just physically taking the modules on the left and creating these bundles or chunks on the right, what Webpack may also have to do is carry out transformations. So for example, if we've got a module on the left that contains React code, JSX, then that JSX has to be transformed into plain JavaScript. Equally, if we've got a module on the left that contains TypeScript, that has to be converted into plain JavaScript. And that conversion or transformation process is performed by what are called loaders in Webpack terminology. Similarly, we may have loaders that transform Sass from the left into plain CSS on the right. So this is what Webpack does, and this is what bundling is concerned with. Taking your source code, looking at the dependency relationships between the various modules that make up your source code, and creating these bundles or chunks on the right. Now, I guess if we then fast forward onto roughly where we left off last week, which began around here. So when we, and this bundling process, this is something that we need to do when we want to create a production version of our application. That is a version of the application that can be deployed onto a cloud service server. And when you are doing this bundling or process, then there are some issues that you need to be concerned with, and I'm listing them here. And these are all concerned with trying to minimize the load time of your application. Now, what do I mean by that? What I mean is when a user navigates to your application, they either have a hyperlink to it or they enter the URL of your web application into a browser. When they hit return, how long do they have to wait before they actually see the home page rendered on the screen. That's what we refer to as the load time. And that load time is influenced by how long does it take the browser to request and receive the bundles from the server, and then it executes those bundles. But in particular, we're concerned with the time period between when the browser actually requests the bundles and they are transported across the network to from the server to the browser. That's essentially what is the main influence of load time. And so it would stand to reason that the smaller the bundles are, then the quicker they're going to be transported across the network. One way of achieving that is by performing minification or uglification on your code. I talked about that the last day. It turns out the Webpack will do that for us anyway. It's also influenced by caching. Now, caching doesn't necessarily reduce the load time for the very first time that a user might use your application. But if a user revisits your application using the same browser, of course, if they revisit your application, then is it possible for the browser to reuse the bundles that they have requested earlier, to reuse those rather than going back to the server and requesting them all over again? If the browser could actually cache the bundles locally, then clearly it doesn't have to wait for the server to return the bundles to them. It can actually use them within its own cache and execute them or retrieve them from there and execute them. I also talked about caching the last A2E, and I explained how caching is supported by the way Webpack names the bundles. And you can go back and look at last week's lecture to clarify that. The third part of this jigsaw is code splitting, and that's really where I want to pick up the story today. Code splitting, essentially, the idea is, if I go back to that dependency graph, so code splitting is where you try and, how should I put it? When the user comes to, when the user navigates to your application, maybe they don't need, let's say, both of these bundles initially. Maybe they only need one of them. They may need this one and, let's say, the CSS. They don't need the other JavaScript bundle. So that means there's less bundles that have to be transported across the network to the browser when the user navigates to your application. So what we would say is that we can split our JavaScript code up into multiple bundles. Okay, I'm just showing you two here, but maybe we could split our JavaScript code into more than two bundles. And how do we actually control that? Or can we influence that from the source code that we write? And the answer is we can. So first of all, code splitting, code splitting is, as I've just spoken to you about it there. Now, we are using Webpack. There are alternatives to Webpack, as I mentioned, and what Webpack does automatically, without you doing anything to your source code, is it splits up let's talk about a React application. It splits up a React application's JavaScript code into two bundles. It does that automatically, so it performs a certain amount of code splitting for you. And if you remember, and I've spoken about this before, two bundles are, one bundle will contain all of the node modules JavaScript code, and the other bundle will contain all of the source code that you have written. As it turns out, just by the way, that code splitting is performed by a plugin, and I'm just mentioning the plugin here. You don't need to know about that necessarily. It's just part of what comes with Webpack, and in particular, it's part of what comes with Webpack when you're using the Create React App tool. I'm very much lecturing this now in the context of React number 1, Create React App, the Create React App tool number 2. So it would be slightly different if you were using a different framework and an alternative to Webpack. but the general ideas are the same. So out of the box, the Create React app tool using Webpack will use this plugin here to guarantee that the JavaScript code that makes up your web application will be split into 2 bundles or 2 chunks, as I've outlined a moment ago. So you get that automatically. But what you can do then is to increase the number of bundles that are created, you can implement what are called dynamic imports. And that's really where I want to focus on today. And what's the objective of dynamic imports? I'm saying is the objective is to split your app's custom code into multiple bundles or chunks. You can actually control it from the source code. And the idea then is that the browser only loads the chunks of bundles. It loads them, we say, lazily. In other words, it loads them only as it needs them. If you don't do any of this dynamic imports, what it means is that all of your custom JavaScript code will be contained in one bundle, and that one bundle will have to be downloaded from the server to the browser at application load time, even though there may only be a small part of that bundle that's actually required to render the home page. All of the other part of the bundle is not really required immediately. But by splitting that large bundle into multiple bundles and then somehow having the additional bundles downloaded from the server to the browser only as they're required, that will achieve better load time of your application, which is the overall objective, as I'm saying here. Just as a by the way, we know this now, that the bundle file name format that Webpack produces follows this naming convention here. It gives a name to each chunk. Then it computes a hash for each chunk. I talked about that the last day. And the extension is always .chunk.js. So we're going to have a sample application to illustrate this. And I'm actually taking this from the Web App Dev 2 module, and I've modified it a little bit. This is a sample application that you would have come across in Web App Dev 2. And maybe if I just run the application and just show you what it does. I've got it already loaded into my VS Code. And I've already actually kicked it off. So I'll just show you it running. I think I've kicked it off. I'll just kill that. So here's my application, okay? And here's the home page of my application. And what's going to happen now is I've got a button here. And when I click this button, I'm going to see a list of movies appearing down here. But it's not until I click the button or the user clicks the button that I need the actual JavaScript code that generates the list of movies. But let's just do it anyway. This just has filtering, which you might remember from before. So if I just type something, it filters the list. So we're not terribly interested in the filtering side of it. Also, if I click on any one of these movies, it brings me to a new page and it shows me the details of that movies. And I'm just rendering it as JSON because I'm not interested in styling or anything here. And you've seen this application in Web App Dev 2, if you remember. So that's all the application does. Now, by default, when I load this application into my browser, when I navigate to this application, what's going to happen is the browser will send a request to my server and the server will return the index.html. The index.html will then contain references to the bundles or chunks that are required. The browser will then send the request back to the server for those bundles. The bundles will be sent across the network. Eventually, they'll arrive in my browser. My browser will execute them, and then it will render the home page. Now, if I don't do anything to my source code, if I don't bother to employ dynamic imports, in other words, let's go back to the slides. So that's how the application works. And this is just a screenshot from the home page. So again, if I go back to here, I'll just do, okay, we'll do a refresh. And you know how the application works now. I've told you, if I click on this, it displays my list of movies. So I'm just showing you an excerpt from the home page. As you can see here, I'm using a state variable to control or to record whether the button has been pressed or not. It's just a simple state variable that's initialized to false. And way down here, then, this is where I'm controlling. This is the component that will display the list of movies. And you can see, though, that I'm doing a condition test. I'm checking what is the value of my state variable. This state variable is the one up here. And I'm saying if the state variable is true, then essentially render the list of movies. If it's not, then render null. Now, initially, because I've set it to false initially, that means when I load my home page initially, this is going to be false. Therefore, this expression here is going to be false. Therefore, nothing gets rendered, and that is the case. I've got my button here, and I've got a very simple little on-click handler, and all the on-click handler does is it changes the value of my state variable. So if it's true, it sets it to false. If it's false, it sets it to true. And so when I click the button, because I've initialized it to false, when I click the button, it's now going to change my state variable up here to true. Because the state variable is true, that means now that my component re-renders, but because this is now true, then this is going to be executed, and this is the component that renders my list of movies. So that's old stuff, right? You should be able to follow all of that really from your knowledge of React. Initially, when we would write this, we would use what are called static imports. Static imports are just the standard kind of import statements that you're familiar with from the web app dev module. So for example, I am importing here the filtered movie list component. That's the component that generates my list of movies in the home page. If I'm statically importing it, and I'm statically importing everything else as well. I'm saying up here that static imports, they're resolved at build time. And what Webpack does is it, as a result of static imports, Webpack will bundle all of your custom JavaScript code. It'll bundle it all into one single bundle or chunk, which is referred to as the main chunk. On the right here, I'm showing you the contents of my React app, this particular app's build folder, which again, you're kind of familiar with both from this week's lab and last week's lecture. And by default, if you're only using static imports, and that is all you have used up to now, then by default with Create React App, in the way that it uses Webpack, there will be two bundles that make up your application. One bundle, which is this one here. This is the one that contains all of the node modules code. So you really don't have any control over that. Second bundle is this one down here. And by default, Webpack calls it name or main, sorry. So main, this bundle here contains all of my custom JavaScript code because I am using static imports in all of my source code. Static imports being these here. So that's the way you would have written it up to now. So we're not availing of this dynamic imports idea at all. And what I'm showing you here is a screenshot from my browser. So on the left, I have my application. On the right, I'm looking in particular at the network tab in my developer tools. And I'll show you this in a moment. But what the network tab allows you to monitor is what network communication is happening between your browser and the server. And so when the user navigates to your web application, to my web application, then what's downloaded from my server is my two bundles. Now, again, as I said, I don't really have any control over the bundle that's named uh, two. The two bundle contains my node modules code. I have no control over that. Here's the one that I can control, but for now, because I'm only using static imports, this bundle contains all of my custom JavaScript code. In other words, it actually contains some of the JavaScript code that I don't really need yet. What do I mean by that? I don't need the JavaScript code that displays my list of movies because they're not being rendered yet. It's only when the user clicks this button that I would need that code. And as well, when the user navigates to the other page, it's only when they decide to navigate to the other page that I would need the JavaScript code associated with rendering that page. So I can potentially reduce the size of this. And the way I'm going to do that is by using dynamic imports instead of static imports. So dynamic imports, I'm saying, are resolved at runtime. Static imports, I said, are resolved at build time. And what the way we do it, and this is again very React specific, and it's very specific to the Create React App tool, is with React. React provides a special function called the lazy function. And that essentially allows us to treat an import of a component as if it was an ordinary import, even though, well, we'll see how it works in a second. So what I'm saying here is that it lets you render a dynamic import as a regular component, as we'll see. Now, as a result of using this dynamic import coding style, in other words, using this function here, and this is really where we're getting at, what Webpack does is Webpack will create separate bundles for each dynamic import. So if you've got 10 dynamic imports, you will have 10 separate bundles associated with your custom code. You'll still have a main bundle, and the main bundle will typically be associated with the home page, but the size of that main bundle is going to be reduced as a result, as we'll see. And so these additional bundles now that are going to be created as a result of using dynamic imports, in other words, using this lazy function, these bundles are actually going to be downloaded from the server to the browser only as they're required, or as we say, they'll be downloaded on demand. How do we actually code up these dynamic imports? And I'm showing you it here. So this is an excerpt from the home page again. And whereas previously we had a normal static import of our filtered friends component, the filtered movies list component, now we're actually importing it using this coding style here. Here's my lazy function. It's part of the React library, and it's a function, and you essentially pass it a callback. It's really usually a one-liner, and you can see my import statement is kind of appearing here. But the effect now of this dynamic import, so this is a dynamic import implementation. The effect is, from a bundling point of view, I'm showing you over here on the right, is I now have a new bundle, and the bundle names are just going from 2, 3, 4, 5, 6. So this bundle here, whose name is 3 and it has a hash value as before, that now is going to contain essentially the code associated with this component here and any of its children. I still have bundle 2, and I still have the main bundle. Main in this case is now going to have all of my source code except the filtered friend list component. That's not contained inside here. So that's how you implement dynamic imports specifically in React. Now, there is another little part to the jigsaw, though. It's fine. Okay, I've got my dynamic imports, but there is still an issue and it is, you have to kind of control the lazy loading or the on-demand downloading of these bundles. Maybe if I just flip back to here for a second now and show you what's actually happening now. So if I reload, gonna up my developer tools, and I'm going to reload my application. Did I run the server? Just give me 1 second now. Kill that. Something happened to my VS Code, I think. Just explain now what the server script is here. If I go into package.json, my server script is, you can see here, I'm just using the HTTP server, and I've already built my application. So here's my build folder here. So if I run my server, and open up my developer tools, go to the networks tab and do a reload. So we can see over here, it had to download bundle 2, which contains my node modules, and it downloaded the main bundle. And I can tell you now that the main bundle only contains the code associated with this, what you see here on the screen. Now, when I click this button here, what you're going to notice over here is that another bundle is going to be downloaded from my server. And that bundle is the bundle that contains the code that allows that contains the code for generating my list of movies. So let's just do that. And again, if you just watch what happens here, here comes my bundle from the server. It's bundle number 3. Now, okay, so in terms of your source code, what you've got to do, as I said, is you've got to implement the import as a dynamic import. But there's a second step that you have to do as well, which is, this is where I'm using, this is the component in question here. Filtered, sorry, now, yeah, filtered movie list. What you've got to do is, and we know this component now is a dynamically imported component, you've got to wrap that component with a suspense component. This is, again, a component that's provided by the React library for you. And really what the purpose of the suspense component is to display something on the screen while the browser is waiting for the download of the additional bundle. I go back again, and I go back to, I just refresh my page. When I click this button here, the browser is going to send a request for the bundle, the additional bundle from the server. But what is the app going to display while it's waiting for that bundle to arrive back at the browser? It has to display something. And that is what the purpose of the suspense component is. It displays something on the screen. You won't see it because it happens so quickly, but it'll display something on the screen. Now, what I just decided to display is this simple message here, building list. Okay, so that's what the purpose of the suspense kind of wrapper is. And all it takes is one argument called the fallback prop essentially. And the fallback prop can be assigned anything. I'm just assigning it a H1 element, but you can assign it anything you want to. You could assign it actually another component if you wanted to. So wrapping your dynamically imported component with a suspense is necessary as well. And I'm kind of explaining up here what the purpose of the suspense component is. So we have introduced dynamic imports into our little sample app. And the purpose of it was to reduce essentially the size of the main bundle. The main bundle is the one that has to be downloaded initially. I didn't show you the size difference. It's going to be fairly minimal because this is a very small app, but it could be significant for bigger apps. And the screenshot here is just showing you what I've illustrated live there for you. Now, continuing on with this code splitting idea, we have what's called root-based code splitting. In the picture that I'm showing you here, I'm just going to give you a generic explanation of what I mean by that. So let's supposing what I'm showing you here is the component hierarchy for some fictitious application that I have. So each of these circles is a component. And I'm also showing you the different routes that make up my application. So if when the user navigates to my application initially, in other words, they go to the root path, then these components here are required, and they're used to render the home page. When they navigate to /page1, these components are used to render that page equally over here on page 2. So arguably, when the user navigates to this application, the only components that we need are these ones here. So our main bundle should only contain those components. We don't need any of these on the left or right. It's only when they navigate to /page1, then we need these components. So we could put these components into a separate bundle. And equally, we could put all of these into another separate bundle. So we now have 3 bundles comprising our custom code. We're still going to have the bundle that contains the node modules JavaScript code. We've no control over that. So we are deciding on how to split our application up into different bundles based on the roots that make up our application, hence root-based code splitting. Going back to our sample app, what that would mean is, click on this. It's only when I click on this link here that the code associated with generating this detail page, that code only needs to be downloaded from the server at that stage. And you can actually see it happened over here. If I go back again to my home page, do a manual refresh, click on this. So bundle 3 comes down. And if you watch what happens over here, it's only when I click on a movie that bundle 4 is actually downloaded from the server. This other one here is the HTTP request that's made to TMDB. So we're not interested in that right now. So how do I achieve root-based code splitting? It's much the same, really. It's the same set of tools that we use. In other words, dynamic imports and the suspense component. So going back to our sample app. So here I am here's my dynamic import of my movie details page. This is obviously the source code that contains the movie details page. I'm dynamically importing it. You can really take this as kind of boilerplate. And here is in my component that contains my routing logic. And you're familiar with this now from Web App 2. Here I've got my suspense component, and I'm essentially wrapping my suspense around all of the routes, and that'll still work fine. I did not have to wrap it around the specific path. This is the specific path that has dynamic imports associated with it. But I'm just I can wrap it around all of the routing logic. And again, I've just decided to display something while we're waiting for the extra bundle to download. So that's how you would implement route-based code splitting. Have your dynamic import of essentially the page that's going to contain your React code for that page and any of its subordinates. And then in your routing configuration, you again use the suspense component, wrap that around the various routes that you have in your routing configuration. So we're now at the stage, if I go back to my sample app, and if I look inside my build folder, just to confirm what I showed you there a moment ago, I have this bundle here, which contains my node modules. I have my main bundle here, which contains essentially now all this contains is the JavaScript code that is necessary just to render this. In my bundle 2, I have the code associated with rendering a list of movies. Sorry, that's not, no. So bundle 2 contains the code that just renders what you see here on the home page. Bundle 3 here contains, sorry, where am I? Bundle 3. There we go. Bundle 3 contains the code that generates my list of movies, and bundle 4 contains the code for my movie details page. So that's reasonably good code splitting achieved there. We will do this in next week's lab. I am giving you the source code for this app. If you look in Moodle, if you want to poke around with it, you can get it here. But in next week's lab, we'll kind of step through taking our application from a stage where it's only using static imports to introducing dynamic imports in the way that I've outlined so far. And this is just a screenshot showing you what I demonstrated there a few moments ago. There's also the possibility, even though we haven't done it in the Web App Dev 2, of having what are called nested routes. So you can see I have 2 nested routes down here, and we could do code splitting there as well. But it doesn't really arise in the Movies app, for example. So kind of conveniently skip over that, but it is a possibility. The final topic is what are called source map explorers. Is there any way, if I go back to here, and I said, if we look at this bundle here, sorry, no, any one of these bundles really, is there any way we can see what code is contained inside in those bundles? In other words, what source code is contained within a bundle? It's all a bit obscure so far. We've no way of knowing. I happen to know what's contained inside in bundle 2, 3, 4, and main, but could I prove it to you? And the answer is yes. There is a tool called a source map explorer, and again we will use it next week. I won't demonstrate it today, but it's a nice visual tool, and what you can do with it is essentially point it at one of the bundles, and it generates this visualization of the contents of that bundle. Each of these boxes represents a source code file. So you get, and the relative sizes of the boxes tells you how much of the bundles, how much of the bundle's size is taken up by any particular module. So it's contribution to the overall module. So we'll see that being used next week. And why that is useful is it could help us to further reduce the size of a bundle. Because what we're kind of looking for, if I go back, what we would be looking for here are what are the really big parts of a particular bundle? And is it possible to split that up further? So this source map explorer, it allows us to see what's inside a bundle, number one, identify the primary contributors to a bundle, and thirdly, it allows us to perform what's called tree shaking. Now, what do I mean by tree shaking? I'm explaining it actually by looking at a specific example. And the specific example actually comes from the app that you're developing in Web App Dev 2. So if I just quickly bring in the movies app that you are developing. And if I drill down into, and this is just one illustration of tree shaking now. There's this util function, and we're using a third-party module called the Lodash module here. I don't know if you remember this or not. So this Lodash is just a third-party module, but it's a module that contains lots of functionality for manipulating objects and arrays, but it's quite a large module. And in fact, I checked the size of it, and it comes in at about 71.1 kilobytes in size. But for our particular movies app, there's only one function within that module that we're using, and it is the truncate function. That's the only part that we need. So is it possible for us to, rather than importing the entire Lodash module, can we just import the part that we need? And it turns out that the way Lodash is implemented, we can do that. And this is how we're doing it here. So because we've written this import statement in the way that we have, see, the alternative we could have done is what you see on the left here. I could have imported the entire module and then access the particular function within it that I need. If I import the entire module, that means that my bundle is going to contain 71. I've got these arrows in the wrong way, by the way. It would contain a bundle, or within the particular bundle, 71 kilobytes of it would be consumed by this large third-party module, even though I only need a part of it. Whereas on the right, we imported the particular part that we needed, and thus we were only consuming 4.5 kilobytes to our bundle, which is a significant difference. Now, the reason we could actually do that is because the Lodash third-party module supported this thing called tree shaking. If you think about it, the visualization is if you shake a tree, lots of leaves will fall off. So and it's the ones that you don't need, essentially, kind of. That's where the term comes from. Now, it's fortunate that the Lodash third-party module supports tree shaking. Many modules don't. So I guess the lesson is, if you're using third-party modules and they're quite large, check to see if they do support tree shaking. If they do, then try and avail of it. And why would you do that? The purpose is to try and reduce the size In this case, it would be reduce the size of the bundle that contains all of your node modules code. That's really only where tree shaking applies to. That bundle that contains your node modules code, which in our case was bundle number 2, if you remember. So when you're doing React development, you would tend to use this source map explorer to look at that particular bundle and see, are there parts of the bundle that you can further reduce in size? And the way you would do that is by checking to see whether the associated third-party module supports tree shaking. And if it does support tree shaking, then you would change your import statements in the way that I've done it here. I wouldn't necessarily be too concerned about that for you guys. I'm just making you aware of it. What is more important for you is the dynamic imports that we can implement in our own source code. So that's this whole area of building an app, and in particular in relation to web apps, it's creating these bundles using this Webpack tool. And we've talked about various aspects of it, like minification, notification, caching, dynamic imports, etc., etc. Right. So in next week's lab, as I said, we will step through the implementation of the conversion of our sample app there from using static imports to using dynamic imports. So it won't be that lengthy a lab, I don't think. You may or may not remember that bundling is part of the assessment criteria for my assignment 1 in this module, in the Agile Software Practice module. So what I would be looking for you to do is certainly to have root-based code splitting in the web app that you are developing for Web App Dev 2 to try and maximize the amount of code splitting that you can achieve. Certainly you will be able to implement root-based code splitting, but you may be able to implement other code splitting. And it's up to you to kind of identify where you might also be able to achieve dynamic imports or code splitting other than root-based.